We do this by highlighting and moving down to the align scan. We'll enter the target model, which is your upper in this case. We will name the opposing, and then we need to align the models. And we do this by a simple method of just putting in a few points on the model so the software knows what orientation the model is. Click on align. We do this by simple method. And then you can see exactly that it's been aligned in with a work environment, and we will lock the models so they won't move. So anything you do from here on in, those models are put together as they would have been when they were scanned. So there you can see. First thing we're going to need to do, I've got connection unstable. Okay, we will. Right. We'll start with the lower, start with the upper, sorry. So we'll hide the lower and work on the upper. As you can see, a prepared model. So what we'll do is we'll take out one of those dies, put a base on it, hollow it, and then we'll start working on the lower. First thing we need to do is trim the scan. Depending on what type of scan you get from a dentist, it will depend on sort of how much work you have to do within Blender. The great thing about Blender is that you get to work on the scans, or be able to work on the scans in quite a lot of detail. So as you can see here, this little window up here means we're working in object mode, and the two modes that you jump between, or this software here will jump between, is the object mode and edit mode. Edit mode, as you can see, puts it into a wireframe format where you can see all of the little vertices, edges and faces that make up the scan. Now this is quite handy for manipulating the scan and creating something that we can use and get a good result from. So the first thing we need to do is trim this scan up to make it look a little neater. So we highlight the scan, put a little vertice down, we move down to arch cut, and there you can see it puts a line down, and we will then map out the area that we want to cut. We work our way around the scan. As I said, depending on how good the quality of the scan is, as you can see, we've got a few jagged edges here. It is possible to manipulate the scan and fill these in to make it nice and smooth. It will really come down to how much effort that you need to put in and what your end result will be. If we're just doing, as we will next on the next scan, an arch, which you're doing a special tray on, you're not going to really need to print the model. So you'll create the model in as quick as possible time, and you won't need to do all this type of work. However, if you're making study models, we've got to make them look good. So we'll fuse the line together, and there you can see we've given the software an idea of where the model gets trimmed. We'll click on the trim. Now what that will do is it will separate the two parts of the scan. There you can see it's cut a hole within the scan. So you have two separate scans on the screen. What we need to do is tell the computer which scan we want to keep and which one we want to lose. Obviously we're getting rid of this area. We do that by highlighting a little vertice and then moving to the clean button, which will then take away the areas we don't want to do. Features like this can be used throughout Blender and throughout model making, Crayon Bridge, or articulation, or any of the modules by cleaning up scans. The processes that you work with initially on the model creator will kind of the other modules use the same types of procedures, which is why it's really important that when you start playing around with Blender, that you get this side of it down to a fine art before we start moving over to the more complicated bits of the software. So once we've got to this point, what we need to do now is put a base on it. We'll scroll down to the upper base option, click on that, and it will put a base onto the model. There you can see. Now, if we wanted to just print this as an arch, we can scale that base so we can make it as small as possible to save on the printing time. For this, we're going to take the die out, so I'm going to make it a bit more substantial. We've got a bit more material to work with. So we've increased that, we'll apply. The next thing we need to do is cut out the die. A couple of features on the die cutting. We've got a make a die and a ditch the die. Now, as you can see from this model here, it's got quite a nice edge. So we're going to create the die from the margin of the die, of the prep. Otherwise, what I tend to do on print models is go around and click on create the die, remove the die, and then manually die trim it, especially if the margin is not very clear. Although the digital side of it is very good, after years of cutting dies, I still prefer to do it manually. But on this occasion, we will take it out from the actual margin of the die. So there we go, we put our point down, move down here to, draw the margin, and then we will work our way around, putting points down on the margin. This is pretty much exactly how we did the arch cut, giving the software indication of where we want the cut to be made. And that's all you're basically doing. You're using the software as a cutout from the mesh. So there we do it. We fuse the line together. To make sure that that cut is 100%, we need to make sure that line is raised above the scan. And we do this by elevating it to make sure that it doesn't intersect on this mesh. If we find ourselves that it won't cut and it won't make a die, it's because this line has sunk below or into the mesh of the actual model. So once we've got that, we click on make a die. Now this area here is where we adjust the dimensions between the die and the model. So that will really depend on the printer you're using, the resin you're using. It takes a few prints just to get this 100%. Once you have, you can set it and then you're good to go every time. We'll flip it over. One of the other nice little features is that you can move where your die emerges from the model. Very handy if you are working on a lower anterior and you have a lot of dies that you need to section. Another little feature as well, usually you find these fit quite nicely within the printed model, but you can also, if you need a bit more retention, we can go around and we can highlight a few of the little vertices on here. S for scale, and then we can put some retention grooves into the die. Once we're happy with that, we'll cut the die out, and there you can see the die is being cut. So what we'll do is we'll hide that, and there you can see the die with the retention grooves in it. Okay, so we'll move on to hollowing this model now. We don't need it to be a solid, so we'll scroll down to the hollowing option. We'll click on Make Hollow. This will produce a wireframe box around the model, so we know exactly that we're in this mode. We have a few options here. The honey solid gyroid, honey vented, and a hollow model. Most of the models now we see coming out of labs printing a hollow for obvious reasons, saving money and time. They've done a few quite nice little extras on here. We'll use the honey vented, which gives you a hollow model with a structure within that. It gives quite a nice feel to the model. It's a little bit more substantial than just a hollow one, which tends to feel a little bit flaky. So we'll adjust the base, and then we'll flip it over, and you can see there the honeycomb within the model. It does look quite nice, and it does sort of make your model stand apart slightly from a lot of the other model systems out there. Once you've got your height of your model to where you want it, we'll apply. Obviously, you can see there that it's obviously moved the model but not the die. So we'll need to adjust the die and cut this down to stop it protruding above the model. So what we use, there's a couple of cutting tools that we can use within Blender. We've got the lasso option, which allows you just to circle something and cut it, but we also have curve and square cutting tools. This is a nice way of putting little holes in. You can either put drain holes in or punch out areas. You've also got a square, which gives you a nice box that you can resize. So what we'll do is we'll go into the square cutting tool. There you can see we can resize, place the square where we need it. We'll move into transparent mode. That will tell the computer only to cut the die and nothing else. Oh, sorry, we'll go back on that. And then we'll click keep outside. There you'll see it's cut away, come out of transparent mode, and there we have the die cut, ready to be printed. We'll bring back into the scene the lower, and we will hide the upper. Now, for the lower, what I want to do is sort of give you an idea of taking out a few steps. So if you've received a scan from a dentist who either wants a special tray or you want to print it off to an aligner or a vacuum-formed stent, you want to do it as quickly as possible. So this scan, you can see it's got a jagged edge, all of them do, but all the information is there. So we'll go down, we'll put a lower base on it. We'll try and put a lower base on it. Let me just bring that back up. I like that. Lower base. We will scale the, I mean, as I said before, we can scale the base. If you are planning to print this, you can make it as small as you can, and then we can print that base off. For this purpose, because I want to show you the articulation systems, we'll make this a little bit longer, make it a bit more substantial. We'll apply that. We will move down to the hollowing options. We'll do a different one just to give you an idea of the options you have on the hollowing. We'll go into the gyroid feature, which will produce a slightly different finish within that. If you're using XCAD or 3Shape, your computer will be amply speed enough or fast enough to run Blender. If you're running it or plan to run it on a laptop, then you will need a sort of quite a high-end gaming type of laptop to work with. This, as you can see now, waiting for the computer to do the calculations will depend on how fast your PC is, depending on how quick it happens. Right, there you can see we've created that. We'll pull this down and expose the internal structure of the model. There you can see it's slightly different. It's got a sort of wavy pattern on it. Quite like this one. It's a good effect. Once we've done the hollowing, we'll apply this. Now, as you can see, it doesn't take long to produce an arch model. So now, effectively, you could export this to the printer and print it. The idea is that it's as straightforward and easy as possible. And I want to give you people an idea of saying this is quite a complicated piece of software. It will do an awful lot of things that you will need it to do within a working environment. But it also, once you've got the basics, you can push out models and design models very, very quickly and have it slightly different from the norm by different effects, putting logos on, different hollowing techniques that are available to you. So for this case, what we'll do is we will now put it on an articulator. You've got several different types of articulator within Blender. As a standard, you have two here. You've got a hinge type and a fixed type of articulator. We will use the hinge here. So there you can see the hinge articulator. We will place it in the optimum area for that. So we can see there, bring it in. Now, clearly, obviously, we need to adjust the articulator. This can be done relatively straightforward. You can see the articulator is made up of two parts. Obviously, because if you wanted to send that to the printer, you would send the model and the top bit joined and the lower part of the articulator joined, and then join them up when the thing is printed. The thing to remember when you're working with this is that if you want to move the articulator, you've got to make sure that both areas are highlighted and that moves together. Otherwise, you end up moving one part and not the other. So we need to adjust this one first. So we go back into the hinge, click on the edit, and then bring the articulator to meet the model. And as long as it intersects with the model that you've designed, it will join. Click edit again, flip it over, highlight the lower, edit, move, click on edit, and there we have it. And that is a completed upper and lower. You'll obviously go around and you can take out the other dies, much the same way as we did with this one. You obviously make your dies before you do the hollowing, because the hollowing needs to be created around the die, not the other way around. The last thing we'll do is put a logo onto the model. So we place our models in an optimal position. We move over to our tabs here where we can find the logo option. We need to enter the target, so to tell the computer that we're going to put the logo onto a certain which model we're going to put it onto. So we'll enter that, and then we'll click on import logo. The import logo you can do yourself. You need to take your logo and change it into an SVG, a scalable vector graphics file, which you can then put within Blender. It's not as hard as it seems. There's a very good tutorial on the Blender website to tell you how to do it. And also, Blender have now put on the option on the website where you can upload your logo, and they will be able to change it into the right format and put it onto your computer. They're obviously charged for that, but looking at what they charge, generally it probably is not a lot of money. Depending on how complicated and how much your how many colors you use on your logo, that's dependent on obviously how difficult it is. Okay, so what we'll do now is we'll obviously scale it. It's a tad too big, as you can see. So we'll put it in the place that we need it. We can grab it. Move it around and place it. Now, what I've done here is that it's got a little bit confused because it should be actually on the upper. So we'll move back a few steps. There's a very easy function if you find yourself and you're not sure where things have gone wrong, to go back a few steps and to actually before the thing started going wrong and then start again there. So what we'll do is we'll put our cursor down, enter the logo, import the logo. There we go. Scale it. Grab it. Depending on the smoothness of your models, and this is where the trimming of your margin of your edge becomes slightly more important. The whole point of this and the whole kind of thing one has to keep in mind is where you want to end up. Whether you're just producing a model to do a try on, and then you can literally take the scan data and delete it, or whether you are producing some high quality precision models, you need to look at it, and when you spend time on it, you can do, and it gives you the option to. So once we've got where we need to go, we'll approve the scale. Now we can change the thickness. Now the thickness will how far the text stands out from the model. So that can be adjusted. Once you're happy, it's set here as a default of 1.5. We can approve the thickness, and then what we need to do is decide whether we want to emboss, where you can see it stands out from the model, or whether you engrave the model. And obviously that clearly puts the text within the model. There are a few other options that we've got here that we can play around with. There's the option to put your logo and sync it within the honeycomb of the model. Now, well, again, you've got to think of where you want to end up. It works very well if you're doing study models and you have large bases that you can put your logo in. Looks very impressive. It's slightly more challenging when you're reduce the size of your models, and a lot of the models that we do digitally now require to be printed, and people make them very, very small. So then it starts becoming a bit of a challenge with your logo, patient's name, putting that onto your models. So that's where we are. From here, we would need to export the models. As I've said before, you've got to think about how they're going to print and what the end result is. But down at the bottom here, you've got an export option, and again, you can export in different file formats. So, for example, if we're going to export the lower, we would need to export the lower with the lower articulator. So you would click on the export, and then you would open up, and it would allow you to export those files to wherever you want to be printed. Okay, so that's the first idea of just getting some models made. What we'll do now is I want to just give you an idea of what a special tray and how easy and quick the special tray can be. So we will delete these models and we will start again, and we'll whip through the process very quickly. So we'll get rid of all of these. We will move back up to import models. We'll import an STL. We'll just do the lower this time, as we're going to create a special tray. So hypothetically, we say this is what you've got for the dentist. Once a special tray done, fine. Okay, so we'll scroll down. We need to put a base on it. So we'll click the lower base. We won't even bother scaling it because we're not going to really print this. We'll print the special tray. So we'll leave it at that. We'll move over to the blue tabs here on the side, open up the tray option. So here we have the tray option, make up a tray, make lower tray. What they've done is they've tried to make it as straightforward as possible. And sometimes they achieve that and sometimes they don't. On this occasion, this is a really straightforward way of making a tray. So we've started here in the lower tray section. We need to survey the lower to make sure path of insertion of the tray is in the correct position. We need to make a blocked out model. And this just allows you to sort of take away any of the undercuts. Obviously on this type of model, it's not so critical, but when you've got partials, then it becomes a little bit more important. So we'll put our point down. What we need to do is now pencil the outline of the tray. And we do that in exactly the same way as we did when we cut and trimmed the first model. So we'll work our way around. The tray module is fully customizable. You can obviously make implant trays with it, opening up for impression copings. We can put tissue stops on, you can do edentulous. And this is where you can see that this software was written by some chap who sat at the bench, because he's obviously seen the problems and the needs that you get in a work environment. If you ever wanted to. Right, so then we'll fuse that line there. As I said, if you want to move the line, we can then shift it into the right place if you're not happy with it. So we've done the outline, then we need to click the auto tray, and this puts down basically a blank, as we would have done with the LightCure stuff, completely over the model. This area here allows you to completely customize the tray. So if you want more impression material between the model and the tray, we can apply that there. We can create a thickness of trays. So if we wanted a thicker area of the special tray, we could thicken it up. And this is the area that we would do if we wanted to create an implant tray in this area here. So in this instance, we're looking at just a normal tray. So we'll click finish the lower tray, and there you go. There you can see the tray has been trimmed to the line that you put down. We have a beading option. This is handy for rounding off. Obviously, if it's in a dentulous tray, that's quite important that we put some beading around it. We can, as you see there, control these little hints down here, give you an idea of where to, how we can adjust things. And once we've got the beading in the right place and at the right size, we can confirm the beading. And there you can see it just puts a nice beading around the outside. Again, it's optional. If you don't want it, you don't have to have it. We need to put a tray handle in. So we click on the lower tray, move the tray handle to the correct position. Again, making sure the tray handle intersects with the body of the tray. If it does, it will join. Again, like all the options in Blender, we can adjust, move, rotate, get things in the right place. It all works along the same keyboard mouse combination. There's a lot of shortcuts within the keyboard. Again, that's the learning curve of Blender. Once you get good at it, once you understand where everything is, it becomes very, very straightforward. So there we have the special tray handle. We have a few options, as always. We can change the view of the handle, put different types of handle on, depending on the finish you want. We'll click on Finish Handle. Now what that does is just create one mesh out of two, and then we'll paint some holes on. This option here allows you to paint the area that you want the holes in. You can adjust again, you can adjust the thickness and the size of this area. Just do this as a speed thing. We'll click on the cut holes there. Wherever you've painted the red, you'll end up with holes, as you can see. Finally, like all of the options within Blender, you can jump between models, trays, articulations. On this one, what we'll do is we'll go back into the model section. We'll put a cursor down in this little area here, and we will add some text. So we'll put the patient's name. We can then scale that, move it, put it in the place that you want. And then again, you've got the adjustment there that you can vary the thickness of the text. We can either emboss it, not very easy to see on here, but if I angle the model there, you can see it's embossed. Or again, like we did last time, you can engrave it, and it will obviously put the text within the tray handle there. Quite an adaptable series. And you can adjust the font. You can, I mean, it works on the same as a computer font. So you've got, you know, how many fonts there are on Word. You can change all of this. Likewise, you can change the environment you work in, the color that you work in, the color of your trays, your models, completely customizable. Once you get used to using it, it's a very, very versatile piece of software. Right. Finally, what we'll do is we will close this down. We sort of learned that, and then I will open another window up. And sorry, I'm working on two screens here, so we'll just have to, there we go. And I'll share that again. Okay, so what we'll do now is we'll bring to the work environment and we'll put some study model bases on. Again, this is very straightforward and easy to do. So we will import the two models that we've got that we had before into the work environment. When we're working with the study model options, it's very important to make sure that we align these models correctly. It's very easy to do that. If we don't align the models will not sit within the study model bases as they should. So it's a step that you can't avoid. So there we put our points down as we did before. We'll align the scans and lock them. We will put model bases on them. We won't worry about the trimming because you've seen that option, and just for the sake of speed, we will create some bases and then move down to the study model area. So here we have the study models. We will then name the upper. I'll highlight the upper, click on name, and there you can see a little thing saying you've named the upper. We will name the lower, and to check that, it's become up lower. We will then import the bases, and there you can see a transparent base with the models set within that base. Now we can move the bases around to place them in the optimal position. If you find your models are slightly too big, we can trim them down as we did before with the arch cut, or we can scale the bases and make the bases bigger or smaller. The base dimensions conform to the US Orthodontic Society, unless you just did what I did there and scale it, and then obviously they won't. They do stand up on all their corners once they're printed, as long as you follow this procedure. So we'll click off that. We will then need to edit where the bases start from. As you can see, these are the dimensions of the bases, and the base will exude from these highlighted areas. We can adjust and control exactly where these bases start and where we're moving them from. So we'll do the upper and the lower, move them into optimal areas. Once we're happy with where we've got, we can then create the upper base, which will exude from here, and create the lower base again, which will move from there. There's a lot of functionality with this study model. We can adjust and we can smooth the transition between the models and the bases very, very easily. We would, if you can go into the wireframe mode, there you can see where the base is attached quite nicely. Here, what we could do is we could do a bit of smoothing and sculpting to make the end result look a lot more aesthetic. Then you would then export the upper and the lower model. You could also put the articulator that we were using onto this as well. We could hollow the models out, put our logos on. Again, depending on how much time you want to spend, the functionality is all there. Okay, so that's basically what I want to show you. I'm going to now go through the tabs and just give you an idea of what Blender have produced, what they're going to come out with in the future. So, as I said before, you start off with a model option. Everything else stems from there. So we'll work our way from there. We have an articulation module. This is a very, very comprehensive piece of software. It allows us to import a fully adjustable articulator where we can put the Bennett angles in. We can change all of the movements within the articulator and place that within the models. We can also import pictures. Quite a nifty way, you can take a very, very simple iPhone or mobile phone picture of the patient, front view, side view, and then import that within this environment and set it up with the articulation. The nice thing about this that I've worked with is that it's a very straightforward way of getting some very complicated information from the dentists. They've really thought about how we can collect as much information as simply as possible and use it within the work environment. We will run some further courses on this this module because it's a whole course on itself. Very, very, very clever piece of software. This I was really very impressed with it. Okay, so that's the articulated. The blockouts. This creates an offset model. So what it does really is it takes the model that we've scanned and it creates another model over the top of it. And this allows you to vary that model, imported model, different sizes. So if you wanted a very tight-fitting tray, but you were using a soft material, you would have a very small offset model to keep your attention. If you have a rigid material that you wanted to suck down or to create onto the model, you would then create a slightly bigger offset model so the thing would fit. It's all customizable, it's all adjustable. Again, like a lot of this, there is a slight trial and error depending on the type of techniques you use and the materials you use to create your end result. But the blockout one is very useful. You will need it if you want to do stents, crown and bridge, and dentures down the line. So this is quite an important part of their suite. We've been through the logo. We've got a bracket option, whereas if you received a file with orthodontic brackets on the teeth and they're coming off, you can easily highlight the bracket area and just remove the brackets from the teeth, and it then reformat and remeshes the area underneath that you've deleted the bracket from. Alignment. Alignment's another very important tool. It's one of those tools that within Exocad and 3Shape works behind the scenes. You don't really have an awful lot to do with it. For those of us using CAD before, when you've done any implant work and you've aligned your scan flag with the intraoral scan to create your implant model, this is you would do, and this is the implant. This is the module that you would need to do that. This also, the ICP alignment also is needed for other suites that will be needed for the crown and bridge, for the denture, the chrome. So although you don't need all of the suites, you kind of have to get an idea of where you want to and what you want to use it for. If you want to use the crown and bridge module when it comes out, there might be some other modules that you will be needed for you to utilize that. It will be made clearer when they release them, and they will give you guidance on that. We've got a bleach option here where we can paint on little reservoirs onto the model of the teeth and to be printed. This was a very good example of how fast the guys at Blender work. Shiraz did ask them if they could come up with some sort of system to put these bleaching layers on for a client of theirs, and within a matter of days they had this written and sent out to people. You're not dealing with a big organization, which in this case was a real benefit because we got the speed there. The downside is there are not hundreds of developers smoothing out and ironing out all the little the problems that come along. This is very much a case of the user getting to grips and understanding how this software works, as well as the dental side of it. We have a guide, implant guide, which allows us to create a fitted guide onto the teeth, varying shapes of access holes and the like. We have a gum, so we can take out soft tissue. So if we wanted to create an area around these teeth, which was a soft tissue area, we could easily do that. Again, it's fully adjustable. You can vary the depth, the emergence profile of the tissue very, very easily. Now, that's what's out at the moment. What we've got coming out is the splint module, and that should be out within the next couple of weeks, I'm guessing. And then towards the end of the year, we will have the crown and bridge module, we'll have the denture module, the ortho module, and the Crow module. And these will come out. I think we're in a bit of a difficult position with the situation that we're in at the moment, so that will those dates may vary. But I think their plan at Blender is to get all the modules out by the end of this year, and at the moment they seem to be producing them quite quickly. So all being well, we should be in a position where if you wanted to, you would just need to get Blender to run and to create all the dental side of things that we need at the moment. You can jump between Blender and XCAD. Not sure about 3Show because I don't use it. But at the moment, what I do is I can make I get intraoral scans from Itero. I can make the model, and then I take that model and I go into Exocad and I can produce the crown within Exocad and then export all of the various bits I need to where they need to go. Okay, Shiraz, I think they're there. Done on my side.
Cool, cool, cool. If you want to stop sharing your screen then. If anyone wants to ask any questions, obviously Andrew's here to kind of answer any queries or further explain any items on that. So by all means, ask now or forever hold your peace, as they say. We are recording this, so I will post this later as well. But as I said, in due course now, we're developing a training facility whereby, especially for the initial modules, that we'll be able to actually, you can buy the package from us, including the initial training course. We'll install the software, and then you'll get the essential full rundown of the model designer and impression tray module moving forward. So, and then long term, as you require further modules, you can buy those, and then we can offer the training on them. It's probably the quickest and safest route to it. You can go online and buy it direct, and then try and ascertain how the videos work. As Andrew has suggested, it is a little bit tricky because it's a module that's added onto an existing software. But obviously Andrew's now been playing with this for a good 6-8 months, and is very expert in this now. So we could help facilitate that quite easily. So there seems to be no questions being asked. There's no one typing anything. I'm hoping that's kind of covered all angles.
Shiraz, Roland said on Facebook about the angles on the study models.
They're the American, from my understanding, isn't it?
Yeah, I'm not. I have to check on that, Roland, because I'm not sure. I'm not an ortho guy, so I'm not an expert on that. But I do know that if you wanted different bases, I can't see it being a problem for the Blender guys to include different options depending on what you want to get out. So we could easily check on that for you.
I mean, they obviously, it comes down to the process of obviously designing these modules and tweaking stuff as we go along. As I said, and Andrew hinted, that we had a requirement for a tooth whitening add-on, which they managed to develop within literally 48 hours for us. So that was quite a simple tweak. So I don't see, now that they've designed the American the ortho base, that I don't see why they couldn't tweak it and give you a couple of options, even to the point that I've actually asked them, and please, Roland and the ortho guys, please don't bombard us as yet, but I have asked them to whether they can actually do pass scoring as well. Now, pass scoring, I know, is a very big thing, especially within the hospital market. And I've asked them to look at it. It's quite a complicated procedure because there's quite a few algorithms to be done, but it's something they are actually considering. Whether that happens this year, I don't know, but now they've got the ortho module, and obviously they can import CT scans, etc., etc. I don't think anything is minuscule for these guys. I think the priority at the moment is the denture and the crown and bridge module, which is quite complicated, and the stent side. But potentially long term we might even get pass scoring as well, which will be a bit of a game changer. So never say never. We'll ask the question. If there's enough demand for it, these guys will do it. So, you know, if there is anything specific that you guys look at, and or eventually when you do start using it, hopefully that you want tweaking, they will do it. They're forever updating. There's now a new update facility in the software that's becoming available, so you can automatically update as you go along with all the latest versions at no cost. Which is the brilliant thing. It's one-off cost, no licensing, and away you go. So for those who are trying to get into digital dentistry, brilliant. It's a punt, and it's a very cost-effective punt. And for those like Andrew, who are experienced in Exocad, who's now adopted this as probably one of their main pieces of software, but still uses Exocad, you know, it's a nice adjunct to what you're already using. And again, as I said, it's a punt. It's not like that. It's so expensive that you can invest in this. So it's definitely worth looking at. So if you've got any other questions that you want to field us or Andrew, by all means, we're on the Facebook group. You can ask us questions, whatever you require, whenever you want. I think there's a few more questions coming in. Before we shut down, I know we've had a lot of time over the last 6 weeks to kind of ponder what the NHS has been doing for us, and you know, and likes of Ian from the St George's Hospital sitting here listening to this. You know, these guys are frontline staff and doing a lot of work for us and supporting us, you know, especially from the healthcare industry. And a lot of people have been affected by this. So I'd like to thank them all in terms of the support that they've done. We're all affected by this. Obviously, I know Alan probably didn't expect this, but Alan's been directly been affected by this week. I'm afraid to say, and we support him in that respect this week, that he lost his mum during the week. So it's you guys in the NHS that are obviously helping us and supporting us, and it does affect us all. We've had time to kind of tinker. This is why we've developed this kind of course. It's another way to communicate and meet everyone. But we do thank you all, and supports with you, Alan, in this testing time this week. And fingers crossed, hopefully next couple of weeks, it sounds like we're all kind of hopefully get back to some sort of normality. We're opening up next week ourselves. But any questions or anything else thereafter, guys, just by all means, just give us a shout. And thanks for spending the time today.
No, thank you. It's been really good. I'm so sorry I came to it so late. That's my only bugger. I'm really peed off by that. But that was excellent. Thank you. And I really appreciate it. If we can possibly, for future ones, share the link, the Zoom link prior to this, is that a thing?
We did do this, Ian. We did share this in the Dent Technicians group to be able to register for it.
I must have missed it then. Okay, well, my bad.
We're trying to make sure. I mean, we have been getting a consistent amount of people on the week, but I did post this last week actually.
Okay, my bad. I must have missed it then.
Yeah, no, we'll just make sure make a more of a deal of it, to be fair.
Okay.
I mean, I don't know
really beneficial.
3 of these
Very
now.
good.
Yeah. So, well, we got the recording, but you know, we can organise something one-to-one as well, Ian, if you want. No problem at all.
Okay. Well, I think my my ortho guy and my restorative guy would really benefit from that one. So, once you've got it up and running, I think I'll copy the link and send them the video so they can.
Yeah, I'll probably post it on YouTube or something, and then get the link sorted. No worries.
Excellent. Thank you very much. How are you all doing anyway? You staying safe?
Yeah, so far so good.
Bored out your skull yet?
Yes.
Well, I'm very happy to say we can go back out motorcycling again. Yes.
And fishing.
Yeah, and fishing. Yes, I saw. Yeah, good for you, man. Anyway, excellent. Thank you very much. I'll leave you to it. Cheers, guys.
All right, thanks a lot, guys.
Bye-bye.
Cheers.